In this lab, we will observe the motion of a soccer ball moving at the same speed without changing direction. Through this observation, we will base all actions on Newton's second law to predict the position of the ball at a later time with known initial conditions, including position, velocity, and a known time. We will then compare the observed and predicted actions to analyze the accuracy of Newton's second law. Utilizing the program tracker, we are able to record and observe position versus time data. If everything is calibrated and the measurements are precise, then the data will be accurate. As you can see, our observed data is demonstrated, and a graph is produced on the right. Position on the y-axis, time on the x-axis. From tracker, these results were obtained. The initial ball position is 0.01800 meters. The initial ball velocity is 0.706 meters per second. The run time is 0.7 seconds. And when predicting the position, we will use Newton's second law to predict the final velocity in order to obtain the position. Having this information will allow us to construct a computational model using VPython. This will provide us with a model that can predict the future. In VPython, the code is as followed. The initial conditions are shown here, the position and the velocity. Delta t is small enough to where our results will be accurate. The while loop includes Newton's second law and the final velocity and the final position plus delta t. And if we run our program, we should get something very similar in tracker. As you can see, the graph produced by VPython is very similar to the graph produced in tracker. Comparing the predicted and observational data on a position versus time graph, we will find that the predicted data is very similar to the observational data. The red line represents the observed position in meters, and the blue line represents the predicted position in meters. The linear graph portrays the concept of Newton's second law, and the idea that an object is moving at a constant velocity will involve a linear relationship with position versus time. The rate at which the object changes position is the same. Variations of the observed position from the predicted position can be accounted for human error in maintaining a perfectly constant velocity. If the axes were flipped while analyzing the video in tracker, the linear activity of the graph will not change. However, the position values will change depending on the placement of the axes. For example, the values will be negative if the ball were to move in the negative x direction. It is possible to say how many pushes and pulls exist if friction and other outside sources are accounted for. In conclusion, this constant velocity experiment was demonstrated by a soccer ball moving at a constant velocity in one direction. This verified Newton's second law that an object's position can be predicted based on a measured velocity.